In this episode, we're looking at sand casting, one of the oldest and most widely used casting processes out there. Large castings for agricultural machinery, bodies for heavy equipment, valve and pump housings, these kinds of big, complex parts are classic examples of what sand casting produces. Let's walk through the full process. Step 1. Special molding sand is packed and pressed inside a pattern to form the sand mold. The pattern itself can be wood, cheap but lower precision, resin, which is mid-range and works for small runs, or aluminum, the highest quality option.
The molding can be done by machine or by hand. For hollow parts, we use a core box to make sand cores. The cores sit inside the mold and create the internal shape of the part after pouring. Before closing the mold, we brush a coating onto the surfaces of the sand mold and cores, then dry it with a flame torch. The coating gives the casting a smoother surface and reduces sand sticking. We assemble the top half, bottom half, and the sand cores together. Everything has to line up precisely. The metal is melted down in a furnace until it reaches the right pouring temperature. The molten metal is poured slowly into the sand mold. The pour speed has to be just right. Too fast and it'll erode the sand, too slow and the metal will start setting before it fills. Once cooled, we shake out the mold. Vibration breaks up the sand and cores and then cut away the sprue, risers, and any extra material. Finally, we grind off the burrs and flash, clean up the surface, and check dimensions and appearance. Only parts that pass inspection go out the door. The biggest advantage of sand casting is cost, fewer process steps, and less material overall. It's flexible enough for one-offs, small batches, or really large parts. The trade-off is that the surface is rougher and the precision isn't as tight, so you'll usually need more finishing work afterward. So it's a great fit for large, complex parts that don't need super high precision, or for low-volume production runs.